Buenos dias, Barcelona. Can you, very good. So, I'm going to talk about smart cities, but I'd like to go back to first principles. We like to start with the way people lived before life was altered by machines. And settlements typically began like this, around a scarce resource. And the size of that settlement was limited to the distance that someone could walk, or typically with a pot of water on their head or carrying a load. So they were limited to roughly 1 square kilometer. And you can see this pattern if you fly over India or Germany. You see a whole series of villages that are relatively close together because that gave access to the fields, to the farmers. You see this pattern if you look at medieval villages and cities. This is one of the most pure diagrams. You can see there's a town center. It's higher density in the middle. You get lower density up to the wall, and then there are the fields for food production right outside the wall. And you literally find hundreds of these examples throughout history in Latin America and Europe and India. And can you all hear me well? Okay, good. You find it here in Barcelona. Actually, Barcelona is really interesting because in the mid, about 59, they took down the walls. They began to expand outside of the city. There was a beautiful system of grids with chamfered corners that worked really well, brought together all the great services of the time, which was sewer networks and water networks and ultimately streetcars. Then cars came, and when you get out to an area like this, it all falls apart. But I'll get back to that. Barcelona is a fascinating case study. But then with industrialization, factories were dirty and polluting, and they were moved to the outskirts of town. Production began to be centralized, energy production as well, healthcare concentrated in hospitals, learning in schools. You had sewer and water networks that allowed for this unchecked expansion. Ultimately, you had horse-drawn carriages and electric streetcars, which allowed cities to expand even further. Ultimately, you had commuter rails, and then the car came. Mass production, 1908, we became car crazy. In the 40s and 50s, we started to design cities that were fundamentally to meet the needs of vehicles rather than people. In fact, in Boston, where I'm from, we cut this huge swath through the city to allow for the needs of cars, and this is where we ended up. So that's my brief history of cities. And this is the model that we've been following for urbanization in recent years in India, China, Latin America. Separate functions, zone them. So you have housing here, commercial here, allow for this low-density sprawl. Try to connect everything by a roadway, make sure you have 3 parking spaces for every car. That worked for a while, but it doesn't scale. And now you have the sprawl of Mexico City or Riyadh or the tower sprawl in most Chinese cities. It's all the same. And I don't think this is sustainable. We're ending up with just unbelievable pollution in Beijing. I took this photograph in Beijing when I was there 2 weeks ago, where the pollution levels were off the charts. You have traffic congestion. I took this out the window of my taxi cab in Beijing on a very good day in Beijing, actually, because if you watch the sign here, it's all green and yellow. There's no red. On a bad day, you have red. We're also destroying a lot of incredibly valuable land with parking. So everything red here is a parking lot or deck in Houston. Imagine if all that could be put to better use. In China in particular, but also in Latin America and India, they're building these relatively high-density ghettos in that there are a lot of people there, but they're single function, and they're almost totally reliant on the automobile. They're dreary, basically unlivable places, in my opinion. We've been looking at density. Density is a very interesting issue because as cities get more dense, a lot of good things happen, but also a lot of bad things happen, and they tend to happen in parallel. So you can see millions of people, this is a normalized scale, so GDP, patents, research and development goes up in parallel with crime and AIDS cases. In fact, recent research shows that cities in particular that have high-density cores, they tend to have more skilled people, higher wages, more innovation, more organizations involved with science and technology and the arts, and much lower water and energy consumption per capita. So a lot of good things come with density. If you do it poorly, and that's Bangalore, and I think they've done it very poorly, you can have increased noise, congestion, air pollution, loss of contact with nature, increased drug use, more disease. So the question is, can you have the good things without the bad things? There's not a direct relationship between density and quality life we're finding. This is a recent study looking at livability on the lower scale, urban population on the upper scale, and you can see there's a mix. This was done, by the way, by a Singapore group, so Singapore rates the highest. And I think the numbers are a little bit suspect, but it points out that you can do density well, or you can do it badly. You can do it well like Paris. Paris is actually a very high-density city. Interestingly, central Barcelona is even higher density, or you can do it badly. So can you have the good things without the bad things? So we've been exploring a whole series of urban interventions or transformations to try to allow cities to increase the density and the livability and reduce resource consumption in parallel. We have a number of strategies which we're advocating. Number one is make a city out of a network of microcities. That's nothing new. That's the way most older cities were, with a network of neighborhoods. But particularly where you put places of living and work and play and shopping all within no more than a 20-minute walk, and you have a rich diversity of enterprises and people. Where I work in Cambridge, you can see that pattern. Here at Kendall Square, it's about a 20-minute walk to Central Square, to Harvard Square, to Porter Square, etc. Each has their own identity. There's a subway stop in the middle because it was a traditional pattern before the car. The 20 arrondissements of Paris have the same pattern. Each has their own identity. In this area of Paris, you have about 25,000 people per square kilometer, fairly high density. And what you find in Paris, but I suspect you'd have the same pattern in downtown Barcelona, you have a very even infrastructure of the attributes related to daily living. So every little dot here is a cafe or a shop or a physician's office or a pharmacy. There's almost nowhere in Paris where a pharmacy is more than a 2 or 3 minute walk, which is really quite extraordinary. In China, they would put the hospital district here with all the pharmacies. You know, slightly exaggerated, but that tends to be how they think. This zoning mentality, which I think is deadly to cities. So we're advocating that you build these microcities, provide 80% of what 80% of people need within a few-minute walk, and then the process of making a city is really creating a mesh network, linking each of these neighborhoods with mass transit and providing the resources for daily living within each cell. That's not to say that everybody lives and works in each of these neighborhoods, but you allow for that possibility. Maybe you bring the cars around the perimeter and bring them in, but you give people alternatives to the private cars within each neighborhood. We've been modeling these actually with Legos, so just to jump scale, that right there is the basic unit that we've been modeling cities with. We call it a Lego unit. At the scale we've been working recently, that's 10 meters by 10 meters by 1 story. And what we're now able to do is to map data to each of those Lego units. So you can map construction cost or revenue or people or energy consumption, vehicles if it's parking, vegetables if it's urban farming. And as you build the city, you're building a data set as you design the city. So for example, that little unit can be 2 workers per day in a Starbucks, or 300 customers. If it's a Starbucks, we can map our micro units to a double-loaded corridor, so 60 people live in that tower. And then we can go through a process of building a computational model and a physical model simultaneously. We found this to be a really interesting tool because we can have even lay people, maybe even mayors, be involved in a process of designing a city. Everybody loves playing with Legos. They find it very non-threatening. And we've been experimenting with this process. This is a Chinese city. It's Nansha, between Guangzhou and Hong Kong. It's traditionally planned. We took these 4 areas, exactly 1 square kilometers. We took the students in a 2-week charrette through a process of designing the cities. These are all color-coded. So black is housing, white is office, yellow is retail, blue is water, green is natural or farmland, etc. And we found we could put together these cities very quickly, but then we do mapping. So we map things to elements in this model to design ideas or data or experiences even. So we have these precedents that really work well to get the density up and the livability up. This is Roppongi Hills in Tokyo. On this street here, you have the Gucci's and the Pradas, etc. So this is the street experience, much like you'd have on Las Ramblas here in Barcelona. But then they have an upper level which are located quiet gardens or restaurant cafes or private areas off of the residential lobbies. And then you have the functional spaces, these towers that can just be extruded as high as you want, because in terms of the experience at the street, they're irrelevant, they're just in background. And you can crank this density way up while keeping the livability high. This is the experience of that upper level, and we've been able to map that, for example, into these models. I was in Valencia just last week, a week before last, and they have a very interesting strategy. This was the old riverbed, Turia, and they rerouted the river. Series of experiences that they created along that. I shot this video one beautiful afternoon where they kept the bridges and some of the water, and it's a beautiful, in effect, it's a super highway or a parkway for joggers and pedestrians and bicyclists, separate from the city, this beautiful, tranquil area with the city around it. And you can go from one end of Valencia to the other without intersecting with cars. Great strategy. This was their original plan. Thank goodness that they didn't do this. This is what we were doing back in the 1950s. They were putting a highway there. Boulder, Colorado is another of my favorite example where you can go along the river all the way through Boulder without crossing over a roadway with cars. This is the bike sharing programs that they have there. Korea, Seoul, Korea, they had an elevated highway, much like what we did in Boston. That was built over a river. They reclaimed the river, took the highway down, and you go from one end of Korea to the other, of Seoul rather, to the other, in this beautiful, peaceful, in this case, very artistic environment. In New York City, the High Line, much the same thing, only it's elevated, reclaimed that the old elevated rail line that serviced the meatpacking section of Manhattan. You have all these great strategies. Now, we took down our elevated highway and we put cars back. One of the great missed opportunities in urban planning with our big dig. Makes me angry every time I go there. So there are good ways of doing it and bad ways of doing it. So that's one. Build these cities of microcities and develop a new pathway that serves people rather than machines. Number two, mobility on demand. That is where alternatives to the private automobile are more convenient, affordable, and hopefully pleasurable than private cars. This is, what is this? Who knows what this is? No? American dream? Everybody has 2 cars. Beautiful, beautiful house, milkman, perfect family. Young people are rejecting this image. They are rejecting very quickly in the US and particularly in Northern Europe, ownership of cars and houses and books and CDs. They're living in a much more lighter weight way. They're moving towards a sharing economy or a service economy. In fact, the cover of The Economist magazine talks about the sharing economy. Very small part of the market right now, but it is a rapidly growing and I think profound new trend which companies and cities need to recognize. This is our image of mobility on demand. These are all the different modes which we are now advocating. The ones in red are the vehicles that we've worked on. And the idea is that you have available to you shared vehicles that provide you with the right mode for the right time for the right trip, acknowledging your physiology. This is the most important one. You should design cities that are walkable, that don't require any mechanized mode. And then shared bikes, shared e-bikes, you need to have trams connecting the nodes. Ultimately, they will be on demand without fixed infrastructure. We have this little folding bike, folding scooter, the folding city car. I'll talk about a couple of these in a minute. But this together makes our mobility on demand network, which we are advocating. This is a little robo-scooter that's designed for very high-density cities where land is expensive. It folds up, it docks, it charges automatically. This is the green wheel, little electric hub motor, so you can give power assist to people. It's good in cities with hills. In China, we're very interested in these three-wheel vehicles that operate in bike lanes for delivering goods. They also provide personal mobility, particularly to elderly people, because they're stable. We've been working on what we call a persuasive electric vehicle. It's a little lightweight folding three-wheel vehicle that encourages you to use a more efficient mode, but it also encourages you to get exercise, and in the process addresses the problem of, we think, energy, congestion, mobility, aging, and obesity. That would be one of the modes available to you in a shared use system. We've designed it to meet the European regulations for a bike lane vehicle, which requires you to pedal, but if you're an elderly person, the pedaling is a switch. Basically, you operate it in electric mode. We're tying this to social biking apps that encourage people to bike together. What one of our young female researchers found is that women are much more comfortable biking with other people. And if you can encourage social biking for commuting and pleasure, people get a lot more exercise and tend to use that more sustainable mode. We're now working on different vehicle architectures for this. It will have a bike-like version, a semi-enclosed version, and a autonomous car-like version, completely enclosed, heated, or air-conditioned. This is our city car, which we launched here in Spain at the European Union headquarters last year. It was a collaboration with one of our sponsors from the Basque region. There are 4 innovations in this vehicle that they incorporated in the commercial effort. First of all, they're robot wheels. In each wheel is the drive motor, steering, braking, suspension that plugs into an unencumbered chassis, allowing it to, number 2, to fold, so it occupies very little space. It's all drive-by-wire. There's no mechanical linkages between the controls and the wheel, and the front door opens so you can step directly into the curb. It folds so the length of the vehicle is the width of a conventional car, so you can get 3 to 3.5 of these in the space of a normal automobile. This is the vehicle on the street being tested in Vitoria. We'll see how the company does with this. It's a very tough venture environment now in Spain, but they do have the prototype. This is Barossa, who launched it for us in Brussels at the EU headquarters. This is our happy sponsor at the time. That's a project which we're completed with. We're done with. Now we're on to a version 2.0, and we think that the autonomy will be a big part of the future. Not exactly the typical Google car autonomy. We are very excited about bringing together these three concepts, which is autonomous driving plus vehicle sharing plus electrification, where they're very lightweight urban vehicles. And together, this makes a very powerful combination. If a vehicle can come to you wherever you are, you drive it, we don't care, to your destination. You get out of it at your destination, it goes on its way autonomously, can park itself, charge itself. We can get a 5-to-1 ratio of vehicles, so that's quite extraordinary. $100,000 per car in an underground parking tech goes down to $20,000 per car in a typical deck in Boston. So if we have these driverless cars in the city in a dense urban environment, and you walk in front of one, there's no driver to make eye contact with, so we think the vehicle itself should make eye contact or at least gesture to you what its intention is. So we're now working on vehicle-to-pedestrian interfaces so cars can exist naturally with human beings in the context of the city. It's an interesting problem that doesn't exist yet, but it's a great problem for us to work on. And then ultimately, you just get rid of all the drivers because they are incredibly dangerous. You know, in the US, there are 30,000 deaths per year because of drivers. That could probably be reduced to 10% of that number if we got drivers out of the loop, but that's some years off. Okay, that's number 2, mobility on demand. Number 3 is what we think of as living space on demand. It's much the same idea, but used to shrink the size of an apartment so that young people can afford to live in the central areas of the most creative cities. This is 2 former mayors, actually. Our old Boston Mayor Menino, New York Mayor Bloomberg, both of them are advocating micro units in their cities to make housing affordable for young people. The problem is young people don't really like these tiny little conventionally scaled down apartments. So we think we can have transformable spaces, much like we have the transformable city car, that allows a very small space to function as if it was much bigger. This is an old video that we did, but it still shows how it cycles from living space to work space to dining space to entertainment space to party space. Architects have been playing with these ideas for many years. The question is, how can you actually do that in the context of developer apartments that would scale to thousands of apartments? This is a study for a New York City developer where you have a living room, dining room, bedroom, living room, dining room for 8, study. The wall slides over, the table goes up, the bed comes down, opens up for a party. In this case, there's the table with the wall that will come forward, and the table goes up, the door slides, you have a bedroom. Very simple strategies that we're playing with. This is a tiny apartment. It's a little over 300 square feet. But here you actually have a very big living room. The bed comes down. It converts into a very big bedroom. And the table comes down. It converts to a dining room for 10 people. So these are the types of strategies we're exploring. We think in that case, you have a space that functions as if it's 3 times bigger. Now, moving these heavy objects should be as natural as opening a door, and it requires some sophisticated sensing and mechatronics that we've been working on to allow for these transformations in a very natural way. This is an apartment that we built that we're testing with people, seeing how natural it is for people to move these heavy walls out of the way. And what we're finding is that young people, when they get back to a conventional apartment, they wonder why they can't just move the bedroom wall over and make the living room bigger. This is a little quick mock-up of a living room that converts to a bedroom as the bed kind of comes naturally down from the ceiling. We've been working on a way so you don't even have to make the bed. These little side arms open up and it pushes the sheets, the linen out of the way. And we're having a lot of fun with this. Now we've started a company to commercialize this, and we think there ultimately will be a lot of a lot of interest because housing is just way too expensive for young people. Okay, number 4, workspace on demand. So this gets back to the sharing economy. This is the future of private work. I believe that you can work anywhere. This is a Starbucks. You see everybody has their back to the wall, little bubble of space. They have refreshments down the street. Nobody can look over their shoulders. They feel very private in a public space. A lot of people work this way, or airport lounges, whatever. There are just hundreds of co-working facilities starting up where they share desks, typically 3 to 1, because at any given time a person's in the office only a third of the time, so they might have 3 times the number of people using the space as they have desks. Shared shops, scarce resources are shared, fab lab, electronics rooms. We've been working on little private work carols for Media Lab students where the desk goes up and down so you can sit or stand or work on a treadmill. You have your own display to the world. We get rid of posters so you can display your current work with a screen that goes up and down to be private or closed. You want more privacy, the side panels pull out. You can back it up to a wall and make a little private workspace. It locks up at night. We can array these into team rooms. So we're experimenting with those kind of strategies. Hyper-efficient use of space. Number 5, urban food on demand. This is an area that we just started in the last year or so, but I think it's among the most important of what we're working on. We define that as where vertical agriculture delivers high-quality produce where it is consumed, addressing food security and water scarcity problems. So you find countless articles about food security, food scarcity, water scarcity. This was in the New York Times about 2 weeks ago. A lot of people have studied the supply chain and how the vast distances that food consumed in cities comes from. And I think that actually needs to change. So I'm an urban farmer. This is my harvest from this summer, from just one day. That's me in my garden. But this does not scale. You know, you can't feed millions of people with these kind of conventional backyard farms. This certainly is not the future. This scales, but it uses tremendous resources. This is industrial scale farming in arid areas. This is our city farm lab that we just finished literally about a month ago. And we're testing state-of-the-art hydroponics on the left and aeroponics on the right. We had our first harvest last week, and here you can see the lettuce, these beautiful big heads of lettuce, no pesticides, uses a fraction of the water, and we fed the entire media lab with the produce from this one little room very efficiently. So we've been running the numbers here. Oh, here you see that's hydroponics on the left, aeroponics on the right. Very different. We can get, if anybody has any questions, I'd be happy to explain all that to you. What we're now working on are strategies that this system can be integrated into facades of buildings with light control. We're actually using the aeroponics for this process, just mist the root balls so there's no standing water. It's very lightweight, although the technology is still somewhat fragile. Ultimately, we'd like to skin the facades of buildings, particularly where the elevator stair core is, and have a market right at the base and produce all this food locally. Now, why would you do this? Well, what we're finding with these numbers, if these are proven out, is you can get 100 times the food production per land area over soil-based farming in a one-story space. It consumes 90% less water, 90% less CO2 if you consider the entire supply chain, 60% less fertilizer, and what I'm really excited about, it really tastes good. So I think the quality is actually very high. Okay, the 6th system, and this was the last that we're bringing, that we're advocating, working on in our group at MIT, is an urban nervous system. That's where sensors and algorithms understand and respond to human behavior and environmental conditions in real time. And you could add other systems to that. So if you go back in time to the early buildings, and we like to look backwards and forwards simultaneously, as I said, buildings were basically like a skeletal system, you know, the bones. And then last couple of hundred years, we were working on circulation systems, so moving water and air and gas. And I would actually include information in this as a circulatory system. I wouldn't put that in the smart cities category. I think the next step, the future, is a nervous system for buildings and cities where you understand things and respond to it in real time. Connected is not smart. There are countless new systems coming out that begin to do this. Just one example, because I know these people, the Philips lighting, where there are occupancy sensors, movement sensors that will raise the light levels as you walk down the street. But see, that's a one-to-one mapping. That's a fairly simple mapping of a sensor to an actuation. At the Media Lab, we've been looking at what a lot of people are interested in, big data, sensor fusion, hundreds, thousands of sensors collecting information, how to put that together in real time, figure out its meaning. That's hard enough, but then going the next step, actually doing something useful with it. These are, every little symbol there is a sensor in the Media Lab. The red is a temperature sensor that's reading at a higher level than the set point of the thermostat. Blue is cooler, so we can get this three-dimensional gradient of temperature. We can also connect to Twitter feeds and other types of sensors. We're having a lot of fun playing with that. But what do you do with this information? This is one example in our lab. It's a project we're doing with Siemens. We have tunable LED lighting. We can change the intensity and the color temperature in real time. We're not using occupancy sensing, but it's activity recognition in that we have a network of sensors that are firing, and we're using algorithms to recognize sitting at a desk, working at a computer, etc. Blue light uses about 30% less energy than full spectrum white light. So we're tuning the color temperature and dimming to see how far we can push the energy savings. She puts the paper down, it recognizes paper, it lights her desk, picks up the phone, the light turns red at the desk. And but this is a study not to see how much energy we can save. That's the easy part. It's to see what the acceptance of this type of technology is to the occupants. And what we're finding is young people love it and baby boomers not so much. And so we have a lot of work to do to really hit the design of this so that it is universally acceptable to people. That's a bigger challenge than just simply saving energy. So we took this same strategy and we thought, well, we can personalize sunlight, possibly. We have an articulating mirror at the facade of an apartment. It allows us to shade all the glass on a very hot day, letting light in through one small aperture. In this case, she picks up her mobile phone. She positions that shaft of sunlight where she wants it and maps that to an activity like using the kitchen island. And if she does multiple mappings, that shaft of sunlight will follow her around during the day. And that requires quite sophisticated sensing and activity recognition to pull that off. What we're finding with this, we can get to a 35% savings in energy, which is huge, but only if we combine these elements. We combine activity recognition plus some aspect of automation, plus just-in-time information so you can give humans control at the right point in time, and persuasive strategies that encourage a behavior change. And you put all this together, it's quite powerful. We're also using little tiny accelerometers that we built in our lab. We call Wockets. And we're looking at, we're streaming that now directly to the phone, and we're doing calorie counts and activity recognition right on the phone. So in this case, nothing has to go to the cloud, nothing needs central processing. We can do it all with these little devices we carry around in our pocket. And I think that's a lot of the future. this kind of distributed processing of complex activity recognition. Okay, so we have all these systems we're developing for the city. I think a lot of them are very good. A lot of people have very good systems. I've come to realize that's not the problem. The problem is, how do we scale this? How do we get it out into the world? There are a lot of good ideas. And one answer we have to that problem is our newest project that we call Cityscope. And we think of this as having three parts. One is a real-time data observatory. Okay? That's collecting data and visualizing that in real time, which is harder than collecting data and post-processing it. Second is an urban intervention simulator, where we can simulate the impact of some intervention on the city, like a multimodal shared use mobility system, or new types of housing, or food networks, or new energy networks. And then the third is the most important, which is a decision support system. So how can you provide information to people in a way that the decision makers, not just the experts, but the people that actually make decisions in a city, can make informed decisions. So this was our model. I don't know how many of you saw this movie. This is Avatar. There are lots of different models. This is a recent one. But here you have people standing around a platform in conversation as they visualize a complex three-dimensional sets of information and make decisions, in this case, about war fighting, but we think we can use the same for designing cities, designing systems in cities, designing buildings. So back to working with Legos. This is our first pass at Cityscope. We're just getting started on this project, but we're quite excited about it. You see where we have a 1 square kilometer area that is modeled using Legos. We have an array of projectors, about 12 projectors projecting information. We can do different types of simulation. This is a wind study in the city. We can project on every surface of this three-dimensional model, including vertical and horizontal. Here we're simulating movement of vehicles and people. We're doing shadow studies. We're now looking at how as we change this physical model, we add buildings, we change the geometry, we rescan it, update the computational model, update the simulation engines, and then adjust the projection of the simulation onto the three-dimensional model. We're also using vertical displays that are around the model, so we can have different types of information that are projected. This is now looking ahead 5 years or so where we might want to go with this. These are little pins that my colleague Hiroshi Ishii did that can dynamically go up and down using simple projection mapping. Now the problem with the Lego models is we can change them, but we can't do them dynamically. What you can do with this type of an approach is you can look at the phasing of the city, or you can instantly compare and contrast scheme A, scheme B, and cycle through studies. Now the fidelity is much lower, but you have the ability to have the fourth dimension, time, in the physical expression of the model. So we've been looking at now combining all of this. We start with this rapid prototype of the city, this three-dimensional model. We take that physical model, we replace it with a white model, we can bump it up in scale, and then we can project this information onto it. So where we're going with this is this iterative design loop. We start with this rapid co-created Lego model of the city. Here we'd like to do it in a process that involves the community, really a co-creation process. Or planners working with the community, get the mayors involved, get the CEOs of the companies who might be tenants in this. Then we scan the model, we bring it into the computational world where we can run all kinds of new simulation tools. We then build a high-resolution white model, we project information onto it, and this can become this iterative loop. We can then tap into this kind of information. This is my colleague at the Media Lab, Sandy Pentland. Every little dot moving is a mobile phone in a taxi cab at night in San Francisco. He's now looking at nightlife behavior. And depending on pickup points, drop-off points, can classify people as members of a nightlife tribe. Young people may go to the clubs, families may go to the family restaurants, et cetera, et cetera. Then you map that back onto the city, and you begin to understand something about the complex demographic and the different typologies, the tribes of a city. And this can be incredibly useful information to designing to this evidence-based design process. We can ultimately tap into this, we think, in real-time streams. Now, what we're finding is you can not only identify nightlife tribes, but the properties of those tribes that they tend to have very similar values. So one group might buy iPhones, the other BlackBerries, or each group may actually have similar diseases. And so all of this information can be synthesized and used in the design process. We're now experimenting with this process in our backyard in Kendall Square, where the model that you saw was a model of Kendall Square where MIT is. We're now simulating the impact of all these new systems on Kendall Square, hopefully to turn it into the ultimate innovation hub. We're very interested in the properties that create creative places. If you look around the world, you find that many cities have these big physical models. This is Shanghai. Of course, these are static models that only deal with one aspect of the city, which is the built form. There's no indication of how the cities function with respect to people or traffic or energy or flow of goods. This is Shanghai, this is Chicago, this is Boston. We think that these models, for not really any more money, it's just a matter of doing it, could be turned into much more dynamic tools that could be used for education of the public, for non-expert decision making, or ultimately tools that experts could use to really refine these types of systems. The systems that we think can be visualized with this type of tool, and we have now done some of them, are these: movement of people, movement of vehicles, flows of goods, energy flows, wind flows, solar access and shadows, flows of money and data, food networks, urban lighting, and then some of my other colleagues that are more interested in the sociological aspects of cities really believe that we can build models to predict livability, productivity, disease, crime, and creative output. What we'd like to do now is to build a common open source tangible platform that can be shared among multiple cities. And we'd like to find a few key cities to work with to build these tools. Maybe Barcelona is a good candidate. Develop a network of partner cities then to share these models, share the data, share the simulation tools, and with each city being a living laboratory such that ultimately the cities would share knowledge about what worked and what didn't work with respect to planning and energy, mobility, food, water, et cetera, so we can have an easier path for the propagation of knowledge and success stories out into the world, because they would all be visualized on a common platform. So, a little bit of technology, a little bit of design, but what ultimately the message is that we have to realize that cities are about people. We have to put people first. We have gotten way off the right path in designing cities for machines. Let's get back, design cities for people, and in the process we will make cities much more livable and I am convinced the same strategies that make cities livable for people dramatically reduce the resource consumption. And it is a global imperative that we get this right, given the global trend towards urbanization. So let's all work on it together. Thank you. Should we? Okay. Nobody else is coming up here, so if we have questions, be happy to take them.
Thank you very much for this really interesting presentation. One short question about how you see the real implication of grassroots community and people in all these really interesting projects, but some of them need new skills, and especially digital skills that most of the people in the city do not have yet.
Yeah. No, that's a great question. I really do believe that we're at a very exciting time where these tools, some of the tools I'm talking about, can come bottom up. You know, people can have access to tremendous amounts of data. A lot of the innovation in cities with respect to tapping into data, looking at apps related to mobility, et cetera, are all bottom up. I don't believe it all can happen that way. I think you need to have, I think the details can work beautifully that way, but you need to have this high-level infrastructure that's coherent, that is put together in a coherent way. It's a little bit like a good musical score, you know, or a script to a play. You know, you need to have really great artists that make that all work as a performance. You know, that's the bottom up. But you need to have this infrastructure that's in place that allows for that creative expression. I think it's deadly when designers or planners try to impose this image. One of the worst projects I've seen in Spain is actually in Valencia, the Calatrava project. I think that's it's beautiful forms, but it's totally disconnected from the city. Doesn't integrate, and I think that's an example of trying to control it in a top-down way. I think when the two, though, come together, then you can have beautiful things happen.
Great presentation. I'm wondering if you could tell us more about the commercialization efforts right now. Mm-hmm. I think there's a little bit of echo here, but how some of the projects you're working on are actually being formed into actual companies and the challenges and opportunities there.
Well, we don't do commercialization at MIT directly. What we tend to do is work with sponsors who then take it and commercialize it. The Hirico project is an example of that. We're now talking with 2 Chinese car companies to commercialize the version 2.0 in China. So we try to facilitate that through companies. The second way is that students or faculty start companies. And what we found is 20 or 30 years ago, you had the big industrial research labs like Bell Labs, Xerox PARC, that filled this gap between academic research and commercialization. And they would pull from academia and feed it into the commercialization for their affiliated companies. Those are largely gone. And I think that gap is now largely being filled by startups. And so I think cities need to encourage these startups, and they need to find more proactive ways then of linking academic research to the startups, who then I think can more easily feed into the larger companies when the business plans and the technologies are refined. So we're a big advocate of that. In fact, we're starting in effect a postdoc program for entrepreneurs at the Media Lab. So if you want a commercial career as an entrepreneur rather than an academic career as a professor, you can go this postdoc path.
Hello, over here. Thank you. I just wanted to ask a quick question. It's an add-on to that. So basically, you see the traditional institutions or private sector adopting these smarter ways of thinking through the startups leading the way. But is there a way to encourage the existing ways of working, maybe for them to think about innovation in the way that they do stuff? So like developers, architects, already established people, not just startups adopting the technology?
Well, the two that you mentioned, architects and developers, they can't really develop new technologies or new products. They have to use things that are on the off the shelf. You know, I'm an architect. I practiced for 20 years in New York, but you don't have get the fees or have the time to invent a new lighting system or really anything. You know, you can put things together in novel ways, but you have to use systems that are proven. So I think that there are a lot of enlightened, adventurous architects and developers that would like to do more in this area. I don't think that's the problem. I think the problem is that the big companies who make the products and services don't actually make what is needed. I think the companies, you have a few that are really trying to get there, but they tend to be very narrowly focused. Well, I won't name a name, but one of the big 3 companies focused on smart city solutions told me that they didn't have a designer or a planner working for them. They were only thinking about the technology for optimizing systems. They were thinking about how to get 2 or 3% efficiencies out of a road network. They certainly weren't thinking about how to get cars off the road. And so I think these companies can think in, hopefully, can think in more creative ways, because they have, until these things get out there into the market, they won't be adopted broadly.
Another question, if I may. Will your presentation be available online? Because you're far more persuasive than I am. And I would like to go and lean on the mayor.
Which mayor, may I ask?
Oh, a small town in the east of England.
Okay. I'd be happy to share this. I have about an 18-minute version of this as a TED Talk, which is a nice digestible chunk. But I certainly, if you want to send me an email, kll@mit.edu, I'd be happy to connect.
Thank you.
In making the persuasive case, I wonder if you could give us some insights on the politics of this. Mm-hmm. You mentioned in one of your examples that you found that youth are ready to leap onto many of these changes, mm-hmm. but the baby boomers were not. Mm-hmm. And I wonder whether you have run into some obstacles from the politics of this.
Yeah, well, it depends where you go. The politics different everywhere. I think that in Europe, in Northern Europe, I'm finding that the mayors are actually very enlightened, and they want to try to do stuff. I've been recently in Amsterdam, Hamburg, or talked with people in Hamburg, Copenhagen, Malmo, Helsinki. I find that leadership to be very good. I was in Tarragona 2 weeks ago, and I love the vice mayor there. I thought he was fantastic. He really wants to try to do innovative things. But I go to China, where we have to fix these problems, and there the politics are so complicated. And the land ownership, the way land is taken from farmers and transferred to the politicians, who then sell it to developers to make money, to feed their coffers. That all, fortunately, it looks like it might be changing. So it's a very long discussion. I actually think, though, that a lot of these innovations will be tested and tried in Europe. Probably will invent a lot of the technology in the US, but we're dead in the water politically, so we won't test it there even. And then it will be deployed at scale in China, commercialized in China, and then they'll sell it back to the US and Europe. So that's probably how it'll play out. Okay, thank you.
I'm sorry. Yeah, we're going to have one last question. Sir, sorry. One last question.
Okay.
Thank you.
Great presentation and great work. That towards the end, the last slide about cities are for people. To what degree can you relate this approach back to, the educational systems, public health systems, and then the growing issue a lot of cities face across the globe, issues of equity and inequity?
Mm-hmm. Well, one thing we found is that the most innovative cities tend to be the most diverse in terms of population and income, and so I think cities do need to find a way to keep a diversity of people in their cities. There's a term, the Manhattanization of neighborhoods, which is really a process of driving out the working class and the poorer people, and I don't think that works. So that's enlightened public policy. Education, we're more into learning. I think a lot of these tools can be used sort of in a bottom-up way, so kids can learn how to be innovators, and that should be incorporated into the educational system. I do think there's we're in an interesting time where a lot of these tools are allowing the democratization of politics and learning and healthcare. I think a lot of the innovation happening in healthcare is happening actually in India, and where they're tiny little devices that communicate with phones, and I think a lot of that will come back and help us in the first world fix our healthcare system. So again, another very complicated issue, but excellent question. Thank you.